All right, what's next? Iterators. We're up to iterators. Okay. When performing operations on elements within a collection, the iterators are essential. This module helps you get familiar with the structure of using an iterator and how to go through the elements within an iterable collection. Oh, okay. So this is just calling next on the iterator. So we've created an iterator. Oh, we haven't created an iterator. We have a to-do. Okay, let's fix that. myfabfruits.iter. So we're generating an iterator for favorite fruits. And it's iterating over the strings. And it looks like we just need to add all of these guys here. Right? So some custard apple, right? And then this one is some, we have avocado, then peach. Right? And then this to do should be just none, right? Once we get to the end of the iterator, we get none. All right, that is iterators 1. What do we have after iterators 1? Iterators 2, unsurprisingly. Looks like there's 5 iterators. In this exercise, you'll learn some of the unique advantages that iterators can offer. To do, complete the capitalized first function. Okay, how's that related to iterators? To do, apply capitalized first function to a slice of string slices. Oh, I see, because it's capitalized words vector. And then apply capitalized first function again to a slice of string slices, returning a single string. Okay, and we want to just do it using iterators. And we have a bunch of tests here. Okay, there's a capitalization function, right? Oh, what is this doing here? So I guess we could say let first equals string. Oh no, we can just say first to uppercase, and does this return a return to 2 uppercase? That's a char. Returns an iterator that yields uppercase mapping of the char. I thought we had, on stir we have 2 uppercase, but a char we have to say next to string. This is probably not what they were expecting. There's probably a better way to do it. And then this should be a string. And if I just say first for now, oh, yeah, we haven't finished these guys. So this works. It's just not what we want. And I'm going to use format again, just because I can. First, and then chars collect. I wonder if it'll know it's a string. Nope, it doesn't. All right, there's probably a simpler way to do that, but this is what I'm doing because that's the first thing I thought of. Is there a 2 uppercase on string? Maybe there's a simpler way to do it. This to be a string from. Can you do a string from char? You can. But we still have the remainder of the iterator to deal with. So we still have to like collect it to a string. Okay, that might be a little simpler. Another option would be, say, to uppercase here. Yeah, I like that one better. Okay. Oh, Mizard says none return string new. Yeah, if there's nothing in the, we could just return directly, right? All right, that's a nice little shortcut. All right, so capitalized words vector. So we're going to take a collection of stirs, right? And return a vec of string. So we're just going to iterate over the words. It doesn't like that because why? Oh. Yeah, I was hoping to be able to do that, but I guess. And this is an amper string. So if we do that, now it's an amper string. And now we can say string here. Yeah. And this is expecting just a regular string. So we can say words iter again. Map string, capitalize first string. Oh. Like that. But now we need to collect all of them into a string. Into a single string, not into a vector. I wonder, will collect work like that? Let's see. Yeah, it does. So collect, because collect can collect into a string, it should be able to just collect into a string, right? But it would be nice if I could do the thing that I want to do. If I put a double ampersand there, can I do this? Nope. Oh, yeah, now that requires this. That's a shame. I wonder if there's a way to do it with the generic type. Oh. Like that. Yeah. Oh yeah, impl as refster. Right. So you should be able to do that. So we can say s impl, no, maybe as ref stir, like that. And then s. I know you put an impl in front of it, but I think that's because you put it inside the parens, right? And then this should be as ref. Yeah, we haven't, I think that as ref comes in later. So it's not something that they would expect you to use here, but this is just like, you know, advanced Rust, I guess. We did it the expected way. So it's fun to play around with the unexpected ways. Let's see if this works. Yeah, so that works, that compiles, and it handles the double indirection there. So yeah, thank you for that suggestion, Scoops. Yeah, so when you can get away with doing a map like this, that's pretty handy. In fact, we saw something similar to that. Let me go back. What was it, errors 3? No, error 4? Error 5? Yeah. No, error 6. Where was it? Where we did the map? There was no error 7, was there? There was something in here that, oh yeah, it was this thing here. This used to say map, right? But it was something, it's a similar idea, right? Parse pause non-zero error, colon, parse int error. Oh no, it's just parse int. Yeah. Like that. Yeah, I think that compiles. But I think the reason this works, you notice that parse int actually has an argument here, or it's a tuple of 1, sort of. but it has this argument and it's not here. And that's because it gets treated like a function call. Somehow Rust treats this like a function call where it just maps it to the enum. So even though there's no function called this, the map can handle a conversion from the trait without the value and just pass it in as a function. So I don't know exactly how that works, but it does. And now I've lost track of where I am. So let's go to the list. Let's go down here. Let's continue from, I'm going to hit C. Yeah, okay. So we just finished iterators 2. Let's go to iterators 3. Division error gives us divide by 0 not divisible. To do, calculate A divided by B if A is evenly divisible by B. Oh, let's go here next. Yeah. And then we have division results, which map the division. And looks like we want either a result with a list like this, or a list of results like this. So the signature here should be result of, it looks like we're using I32s here. So this, I guess, would be a vec of I32 or a division error. And this function signature should be a vec of result of I32 or a division error. This looks like what this is, right? It's a vec of results. And this looks like a result of vecs. And I believe, again, we can just collect these up. Oops, I hit Control D. I shouldn't have done that. Yeah, and that actually passes the tests, which is bad, right? Because we never actually implemented divide. So how does this pass the test? Oh, because it's on traits 4. Oops. Oh, somehow I undid lifetimes. Did I break this? I'm going to hit continue at. Okay, there's iterators 3. Okay, so yeah, all the tests fail because we haven't implemented divide. Okay. Too confusing. So let's implement divide. So let's do like we did last time. Match b.compare to, and remember the ampersand this time, 0. Oh no, we're saying if it's divisible by, if we have a divide by 0 error, or if it's not divisible. Okay, so it's a little different. If b equals 0, then we're going to turn error, division error, divide by 0. Else if b mod a is not equal to 0, then we're going to say error, division error, not divisible. Otherwise, we're going to return b divided by a. Oh no, a divided by b. And this is okay. Is there anything else I'm missing? All right, so that worked. Is there a simpler way to do this? I'm not seeing anything quickly off the top of my head. Isn't there a remdiv function? No, I thought there was. Maybe I'm thinking of Python. Or div rem. No. Oh well. I thought there might have been. I don't know if there's a simpler. Wizard says there's a divrem crate. Okay, that might be a little beyond the scope of this one, though. We could still do a match, right? I can say match B. If it's 0, then it divide by 0. Else, if it's anything when A divided by B is not 0, then we can do this not divisible one. Otherwise, that. Will that work? Yeah, so that passes as well. Maybe that's a more rusty way to do it. And I think the way the match works is it in order from the top. So we won't hit this line if B is 0, because this obviously will fail if B is 0. Scoop says match B comma A divided by B comma A mod B. Yeah, except if B is 0, you blow up, right? But that's an easy way to. If you don't have that situation where you need to check for B first, we could do if B equals 0, return divide by 0. And then say A match A over B, A mod B. Or the other way around. Right? And if it's 0 anything, then we can OK X. Otherwise, if it's anything else, then it's this. Will that work as well? Yeah, that works as well. But I'm going to go back to my match statement. Oh, I went too far. There. Mizard says checked div and checked rem. Oh, yeah. Let's see what result we get with that. Let x equals a checked div b. And that gives us an option, I32. So that means that we would have to map the option into a result on none. Now, I know that you can iterate on options. So will map error work? Maybe? No. The type here is bang, which is the invalid type. So it won't let you, maybe I can say iter here. No, that doesn't work. Wizard says match A checked rem B, none sum underscore. Oh, I like that. Right, because then we get, if it's 0, then we return OK. Right? Oh, expected option. So it has to be sum 0. So if it worked, oh, there's the OK or, right. There's a whole bunch of ways to do this. If we have a none, then we have not divisible. Oh, yeah. How do you distinguish in checked rem between not divisible and divide by 0? Oh, it would be, I see. Yeah, so this is divide by 0. I just read the docs. Some zeros and OK, and anything else is not divisible. Look at that. Ah, that also passes. I like this one. But yeah, there is the check div OK or, right? And that would allow us to map the error into division error. Right? But I think this one's the one I like the most. I don't want to say it is the best because that's just my opinion, man. This is the one I like the most because it's pretty clean and it shows exactly what you're going to do. If we get a division by 0 error, if it divides evenly, then we could just return the division. And if it doesn't divide evenly, then we just return that. What would be cooler is if not divisible. I don't know where that's used in the tests. But we can actually have it say what the remainder is. Right, now it's going to blow up that one test that uses it. Oh, sum. Let's call it remainder. Like that, right? And then we got to fix the test here. If we can think of the number, what's 81 divided by 6 remainder? 5. There. Okay. How's that?